Okay, continuing with the linear transformation topic. Suppose if we have a transformation given by this function, this formulation. Okay, so transformation of a vector x1, x2 into a vector that will be 2x1 square and x1 plus 1. So if we have this type of transformation, so determine whether it is a linear transformation or not. So for example, for the linear transformation of for example, if we have for a linear transformation, so we know that we have these two kinds of conditions. Tu plus v is equal to tu plus tv, and t r times u is equal to r times t u. So maybe if any of these condition is not meeting, that means then that transformation will not be a linear transformation. So suppose if we take any values x1 or x2, say if I take x1 as 2, x2 as 1. So by this transformation, by this formulation, so this transformation will be equal to this 2 times 2 square, okay, because this is x1, and then it will be x2 will be then x1 plus 1. So it will be x2 will be then x1 plus 1. So it will be 2 plus 1. Okay, so it will be then 8, 3. Okay, so this is the one. Okay, and then if we take something like it's this is tu. Okay, so this is actually tu. If we take r, any scalar r as say maybe 2, so if we want like 2 times this 2 1, okay, so then it will be t 4 1. So it will be then, if we apply this transformation, then it will be 2 times x1 square, 2 times 4 square, and then over here it will be 4 plus 1. So it will be different value, 32 5. Okay, it will be 32 5 in this case. So so this is here, and then r times tu will be r times tu is r is 2, and then tu was 8 3, so it will be 16 and 6. So 16 and 6 and 32 and 5 are not same, so it means that this is not a linear transformation. Okay, so for the linear transformation we must meet any of these two conditions. So we check with this condition, we can even check with this condition, but since this condition is not meeting, we don't need to check with this condition as that. So but we can do it as well. But anyway, we can say that it is not a linear transformation because one of the condition is not met for the linear transformation. Okay, so for the linear transformations relating with the matrices and the vectors, so the obvious transformation is Ex is equal to Ax. Okay, so for this transformation we have two types of conditions. Okay, situation, two types, we have two types of these transformations. One is called as the 1-to-1 transformation, and the other is called as the on-to transformation. Okay, so if a transformation will be 1-to-1, if a transformation will be 1-to-1 if for every vector there is at most one vector in the Rn. So that means if we are in the, so that means if we transform from Rm to Rn, that means then for every vector in Rn there will be at the most one vector in Rm. Okay, so this is the definition of the 1-to-1 transformation. The meaning of onto transformation is that for every vector in Rn there will be at least one vector in Rm. Okay, so that means 1-to-1 means that means at most one vector. Okay, and whereas in onto and there is at least one vector. Okay, one vector. Okay, the meaning is very actually the application of this is very simple. For example, if we will do this transformation and then we will make their augmented matrix, and if that augmented matrix results into the echelon form, and both the rows and columns have the pivot positions in the echelon form, then that transformation will be a 1-to-1 transformation, and then similarly there will be an on-to transformation. So I will explain it with the help of the example. Okay, so example is this. So for example, if we have A 2-1 1-1, and then we are using the same transformation. So in this case x will be like x1 x2. Okay, so we want to determine whether the transformation, linear transformation, is 1-to-1 or on-to transformation. Okay, so for this determination what we will need to do is we will need to write this matrix 2-1 1-1 and convert it into its echelon form. So in this case we can easily convert it into the echelon form by taking this 1-1 and 2-1 as replacement. We can replace these two rows, replace row 1 with row 2, interchange row 1 and row 2, and next for the echelon form we make this as 0, so 1 1, and then -2, so 0, and then -2 plus 1 is 1. Okay, and -2 times 1 is 1. So that means what we have done is -2 times row 1 plus row 2, that is the new row 2. Okay, so 2 minus 2 is 1, 1 minus 2 is 1 minus 2 is -1 over here. Okay, so in this case, and then from the next step what we can do is 1 1 and 0 and 1, we divide the last row by 1 by minus 1 times the minus 1 times the row 2, that is the new row 2. So what we get over here is 1 1 and 0 1. So now this is the matrix in the echelon form. So this echelon form, we can see that every column has the pivot position. So for example, this first column has this pivot position of 1, and the second column also has this pivot position of 1, and similarly this each row has the pivot position over here. Okay, so if every column has the pivot position, for example, if we start for the column, we start from here. Okay, this column has the pivot position of 1, and then this first column has the pivot position of thus 1. So these two are the pivot positions or the columns, and similarly for the rows, these two are the pivot positions of the rows as well. So if every column has the pivot position, every column has pivot position, then the transformation will be 1 2 1. Okay, and similarly if every row has pivot position, then the transformation will be also called as 1 on 2 okay, on 2 and 1 to 1. Okay, so this transformation, which will be using this matrix 2 1 1 1, it will be both 1 to 1 and on 2. Okay, let's see another one. In this case we have 3 0 minus 1 1 2 3. Okay, so what we can do is we can convert it into its echelon form. So we can interchange the rows, but this is just optional. What we can do is 3 0 minus 1, we can make it as 0. So divide by 1 by 3 this one, so it will be minus 1 by 3. That means 1 minus 1 by 3 row 1 plus row 2. So it will be row 2. So it will be 0, and then it will be 10, and then it will be 1 by 3 plus 3. So that is 1 by 3 plus 3, that is 5 by 3. Sorry. So minus 1 by 3, and then this is this will be, so it will be plus 1 by 3 plus 3, so that is 1 by 3 plus 3, so that is 10 by 3, right? 10 by 3, 10 by 3. So now in this case, if we want to determine whether it is an on 1 to 1 and transformation, so for 1 to 1 the answer is no, 1 to 1, because one of the rule is that if n is less than m, then is not, that transformation will not be 1 to 1, not 1 to 1. So in this case, because n is the number of rows, so 2 rows, and then m are the number of columns. So if the number of rows are less than number of columns, so then it will not be a 1 to 1 transformation. And for onto, we can look at this echelon form. So in this case, we can see that every row has the pivot position. So for example, and this first row has the pivot position as 3.